The plastics in your home, the synthetic fibers in your wardrobe, and the fertilizers that grow your food all trace back to a foul-smelling liquid buried miles underground: crude oil. Early civilizations like the Mesopotamians and Egyptians used oil that naturally seeped to the surface, applying it as a basic sealant for boat hulls and as a preservative for mummies. By the 4th century, the Chinese had developed shallow extraction techniques, using hollow bamboo pipes to pull oil from the earth to boil brine for salt production. Despite these early uses, humans spent centuries looking elsewhere for their highest quality light. For most of the 18th century, illuminating the world relied on animal fat, a dependence that was about to trigger a global ecological crisis. To light cities like London and New York, the whaling industry expanded on a massive scale. Hundreds of ships were dispatched to harvest whale blubber to meet the rising demand for oil. By the mid-1800s, several whale species were near extinction. The pressure on the species only eased when Edwin Drake successfully drilled this deep well in Pennsylvania in 1859, proving that oil could be harvested from deep within the earth. This breakthrough caused an industrial boom, with wooden derricks crowding hillsides to meet the sudden, intense demand for cheap, odorless kerosene. At the time, drillers focused exclusively on kerosene. They viewed the rest of the raw crude as waste, dumping it into rivers and unknowingly discarding a chemical storehouse that would eventually sustain the modern world. Crude oil is the compressed remains of ancient marine life. Millions of years ago, phytoplankton sank to oxygen-deprived ocean floors, buried under silt. Over time, these layers moved deep into the crust. Under 600 psi and 350 degrees Celsius, this matter transformed into crude oil. Today, finding this oil miles underground requires seismic survey vessels. These ships use specialized equipment to map potential reservoirs without drilling blindly. These ships bounce powerful sound waves off the different rock layers beneath the seafloor. Sensors record the reflections to generate a 3D computer map of the hidden oil reservoirs. Mastering this extraction gave humans access to a vast energy source, but unlocking its full potential meant learning to break it down into its core chemical components. Refineries separate crude oil into usable products inside distillation columns. By heating the crude, engineers capture different substances as they boil off at specific temperatures. The lightest layers, like cooking gas and petrol, boil off at the lowest temperatures at the top. Between 120 and 180 degrees, naphtha emerges, forming the base for synthetic plastics. Further down, at 320 degrees, we capture kerosene and diesel, which powers modern aviation. The heaviest layers yield furnace oil, which powers massive cargo ships, and bitumen, the leftover material used to pave our roads. Oil provides the gases needed to synthesize nitrogen into ammonia. This process creates the fertilizers used to increase crop yields for the global food supply. Crude oil is the chemical scaffolding for modern transportation, medicine, and food production. Our current global systems for moving goods and feeding billions of people are built directly on this massive petroleum foundation. Utilizing every part of the barrel built our current industrial infrastructure, but maximizing the utility of oil also meant maximizing our carbon output. Burning these high-density hydrocarbons releases large amounts of CO2 that had been stored underground for millions of years. This accumulated CO2 traps solar heat in the atmosphere. As this heat is held close to the planet, it drives global warming and creates instability in the Earth's ecosystems. The same discovery that saved whale species from extinction and enabled modern industry is now the primary factor driving global climate change. Addressing this requires a transition away from fossil fuels toward a renewable energy ecosystem built on wind, solar, and other sustainable technologies. The challenge lies in replacing the concentrated energy density of fossilized carbon with real-time energy harvesting at a global scale. History shows that humans can change energy sources when the stakes are high enough. Just as we transitioned from whale blubber to kerosene to save a single species, we are now attempting to move past fossil fuels to preserve the global ecosystem.